Lesson 42, finding distance from a point to a line. So when you have a line and you have a point away from the line and we want to find the distance, we will find the shortest distance, which is the perpendicular distance, and there's only one perpendicular distance to the line, and this distance will be the shortest. So if you are given a line y equals 1 and the point 6, 4. If you have a y equals 1, that's a vertical line. Here we'll, wait, y equals 1 is not a vertical line, it's a horizontal line. So here's 1, whoops, everything is not very straight here. So this is y equals 1, the point 6, 4 is right there. The perpendicular distance, it will be a vertical line. So it's just how many units from the 4 to the 1?
3.
So it's 3. You can just take your y from your point, subtract the y in your line, and get 3. That way you wouldn't have to. So we took our 4 from there, or 1 from here. That's only if you have, if y is a horizontal line. If you have x equals, then you would take the x value from your point and subtract what the line is. Or you could draw it and figure it out from there. So here's another example from y equals 2 to the point P 7, 3. So this is very similar. You only have to do 3 minus 2, and it will be 1 unit away. The one that, if you want to find the distance from x equals 2 and to the point 7, 3. Now x equals 2 is a vertical line, so it's just the distance from the x value in your point to that vertical line, x equals 2. So it's just 7 minus 2 equals 5 units. So those ones are a lot easier. We're going to do a little bit harder of one. So y equals x. Now we have introduced a line that is not vertical or horizontal, and we want to go from the point 7, 3. So you have to find the perpendicular line that goes through point 7, 3. Okay, so we've got to find that line, the equation of that line. The slope will be -1, because that's the opposite reciprocal of 1. X is 7, y is 3, and we can find b by plugging in y equals m times x, -7, plus b. So we add 7, b is 10. So the perpendicular line that goes through 7, 3 and is perpendicular to y equals x is y equals -x plus 10. Now we have two lines that are perpendicular, and we want to find the point where they intersect. Do you know? Can you see in your head why, or do I need to draw a picture?
Yeah, I see why.
You don't have to graph it. To find the point where they intersect, you can use algebra, and that is by setting both of these equal to each other. So where they intersect, the y's will be the same value, right? Because they're going to be on that same point. It's going to be an xy point. So we're going to say x equals negative x plus 10.
And y would have to equal x. So it's gonna be like a.
Well, that's what, yeah, y equals x and y equals this. So I just put x equals that. So they're both equal to each other on the point of intersection. So I add x. So x equals 5. And then since y equals x, y will be 5 also. So now thank you. So now I have to find the distance between the point 5, 5 and 7, 3. So we use the distance formula. Find the distance between 7 and 5, which is 2, and square it. Then add the distance between 5 and 3, which is 2, square it. So you get 4 plus 4, or square root of 8, which simplifies to 2 root 2. So the distance from the point 7, 3 to the line y equals x is 2 root 2. Okay? You can draw it if you want, but this point won't always be pretty. Okay? I mean like whole numbers. You might have decimals, and that's really hard to see on a graph paper. So I think it's easier to do the algebra for it. Kaden?
I see how you got the y equals 5. How did you get the, or no, I see how you got the x equals 5, but how did you get the y equals 5?
Oh, because in our equation, y equals x.
Oh.
Or you could have plugged it into here. Y equals negative x plus 10. So you'd get 5 at both times. Okay, Rebecca?
So what are we trying to do? Are we trying to find a line perpendicular to a line?
We are trying to find the distance between a point and a line. And the distance that you use is the shortest distance, which is the perpendicular distance. So we have to do all these steps. We've got to find the perpendicular line, find where they intersect. Now you have a point that you can find the distance between those two. Okay, Benjamin?
Okay, I was kind of confused on how you got the x value. Because I kind of get how y equals x, so,
And then this is the perpendicular line.
okay.
So if you have y equals x, y equals negative x, like that, you know,
Mhm.
they're going to cross right here.
Yeah.
And the x and y's will be the same. So if y equals x on this line, and y equals negative x plus 10 on this line, we can set them both equal to each other to find out what x equals.
Okay.
So the y's will be the same, which just means I've
So you
substituted
just
in.
set them equal to each other?
Yep.
Alright.
So I'm going to write down the steps for you. So you can just follow the steps of finding the distance between a point and a line. Yes.
Will we ever have to justify it for homework?
Oh my goodness, I have no idea, but I don't think so. Okay, so this is an example. Line y equals x plus 2 and the point 4, 4. So step 1, you need to find the equation of the perpendicular line through the point. So I'm shortening that to find equation of perpendicular line through point. Okay, that's the first step. So with this example, we know the slope will be -1, x equals 4, y equals 4, so we'll do 4 equals -4 plus b. So b will be 8, and the equation will be y equals -x plus 8. So there's step 1. Step 2 is set the equations equal to each other. So y equals x plus 2, so we do x plus 2 equals -x plus 8. So then we, add x, subtract 2, so 2x equals 6 and x equals 3. And then you take that value, plug x into one of your equations. So either the given or the one from step 1. So we have y equals x plus 2. So we plug in x, so y equals 5. So we find that 0.35. Plug it. And then find point, so of intersection. I don't know if I should make that a step or just in the same step as step 3, I think. We'll just do that. Okay, then find the distance between your given point and the point from step 3. So we're going to use the 0.44 and 3,5. So the distance is the square root of the difference of the x's, so 1 squared, plus the difference of the y's, which is a negative 1, but we can just do 1 squared. Same answer, so it's root 2. So we have several theorems that we are going to
Ignore.
We are? No. Okay, we can. We could probably ignore some of them. So, one of them states that the shortest distance between a point and a line is a perpendicular distance from the point to the line. The other one, there's another one that says the perpendicular segment from a point to a plane is the shortest distance between,
That pretty much just says the same thing.
shortest segment from the point to the plane. So, we're going to go ahead and write that as one sentence. So the shortest distance between a point and a line, and in parentheses put plane, is the perpendicular distance between, or from, I guess between the point and the line, parentheses, plane. So that's two sentences as one in one. First you read without the parentheses, then you read without the line before and the parentheses. I don't know if that makes sense. The shortest distance between a point and a line is the perpendicular distance between the point and the line. The shortest distance between a point and a plane is the perpendicular distance between the point and the plane. Then the last theorem is if two lines are parallel, all points on one line are equidistant from the other line. So if two lines are parallel, then all points on one line are equidistant from the other line. And that should make sense because when they're parallel, the distance between one point on one line is gonna be the perpendicular distance to the other line, and so that distance is gonna have to stay the same in order for them to be parallel so that they never meet. So it's kind of intuitive. Okay, that's it.